What's up, you guys? Welcome back to the channel. In today's video, I'm going to show you how to create this classic water sort color sorting game in Python from scratch using the PyGame module. So this is a really popular type of kind of just distraction game that everyone has on their phone right now. It's just essentially you get like a scrambled series of tubes that have these different color blocks in them, and the whole kind of objective of the game is to sort them out so that you get just all tubes with one color in each tube, and that's kind of the whole objective of the game. It's really fun, it's really popular, and it's actually surprisingly simple. So we're going to go through line by line and code it together in this video. If you don't want to watch the whole video, or you want to grab the code ahead of time and just sort of follow along, I will leave everything you need in a GitHub link that you can find in the description of this video as well. And I don't normally say anything like this up front, but please remember to leave a like on the video. Don't forget to subscribe to the channel for tons more great content. If you find this sort of thing enjoyable, if you like all these big projects we've been building together, consider checking out my Patreon page at a link in the description below as well. That sort of support really helps me grow this channel and do lots of fun, cool projects like this. Okay, so without any further ado, let's get right into building this project. All right, so pretty much as always with any game or any big Python project, you're going to have modules that you need to import right in the beginning. And for this one, PyGame is the most obvious one because it kind of has the framework that we're going to build the game within. But we also want our level to have an element of like random generation when we create it. And then we want the ability to kind of reset a level and go back to how it initially spawned in if we get stuck. And so for that, we're going to want the copy module as well. And these are just the three modules that you'll need. And you can see they're gray in my project right now just because I'm not calling them yet. But as soon as we use them in the build, they'll go to whatever your color standard is that says they're in use. All right, so next thing we're going to do is initialize PyGame. And we are going to just do that with pygame.init like that. And that just sort of allows you to call any of the functions within the PyGame module without having to say like anything additional. It just makes the whole PyGame package available to you. All right, and now we'll just do setup game variables in the beginning, and you kind of need this to establish your overall screen size. And I'm just going to use a width of 500 and a height of 550 because this really is just kind of a little widget game, but you definitely could have it a little bigger if you wanted to. And then for the screen, it's just going to be pygame.display.setMode, and then inside these square brackets, you're going to want to give it a width and then a height, and I like to define those in these separate variables, which you'll kind of see when we get to the point where we're drawing the tubes, because we're going to use width and height to sort of evenly space things out. All right, but so then that's all we have to do to set the screen. And then I don't always do this on my projects, but we're going to set the caption as well. So pygame.display.setCaption, and I'm just going to say water sort puzzle game. And so this is all you need to have the top text. Instead of it just saying like PyGame window, which I believe is the default, now it'll say water sort puzzle game. Okay, and so a couple more things that we always do is we're going to want to set up a frame rate and then a timer as well that'll control how fast the game loop operates at. And this is just a smart way to make sure that the program runs pretty much the same on any machine that you would be opening it on. So we're going to set up this clock in a timer variable and then a frame rate of 60. And then we're going to establish a font. And anytime that you want to have some text in your PyGame games, you just want to set up a font in the beginning with pygame.font lowercase f and then .font capital F. And I'm going to use Free Sans Bold. Some people familiar to the channel know I use this a lot because it comes built in with pretty much any installation of Python and PyCharm. Your computer's just going to know what this is. But if for some reason it doesn't recognize this font and it's Free Sans Bold, not Free Sans Old, if your computer doesn't recognize it, you just need to drop a TTF file in your project folder and then address it here instead. And then I'll just use a pretty good size font of 24. So that makes it easy to read, but it's not so huge that it like overpowers the screen. Okay, and now we're going to go ahead and set up the main game loop where stuff that runs over and over while the game is playing gets populated. So we'll start with run equals true. That's just going to be our game running variable. And then we're just going to say while run. And here's where we put a few generic things that happen every scan. So first, we'll just be screen.fill, and I'm just going to fill it with black. It's kind of an easy default background color, black or white, because most colors look pretty good against a black background. They're pretty easy to see. And then you do timer.tick at our frame rate that we established. So that just kind of controls the speed that your code runs at. And then really all else we have to do to just get the basic window opening is for event in pygame.event.get. And this is going to be where we put all of our event handling. And this is going to be our main game loop. And I'm trying to put more comments in. That's always one thing that a lot of my viewers ask for. They say I don't really leave a lot of comments, and that is true. So I'm trying to get better. Alrighty, so for event in pygame.event.get, we're going to say if event.type is equal to this unique one, which is just pygame.quit, like that. And that's the red X in the top of the window. So when you boot up any PyGame window, by default, it has a title bar that has a red X in the top right. And clicking that is pygame.quit. Okay, and so if you quit, then we're going to set run equal to false. And then we're just going to say down here pygame.display.flip, and then pygame.quit. So you'll notice my indentation is pretty important here. This display.flip is at the end of my while loop, but still inside my while loop. And then pygame.quit is outside of the while loop. So the only way you get to this line is if run equals false, which happens if you press the quit button. And this is what runs at the end of every while loop. So we'll put a comment here that says display.flip draws items onto screen, and then quit exits program. Okay, so now if we boot this up, just this shell, it should give us a window that's 500 by 550. You can see the title says water sort puzzle game, and it's really cool. We've set up a window just like that, pretty easy and straightforward. Okay, so now it's time to start actually generating stuff. And I think the first thing we're going to want to do right below timer.tick is we're going to want to generate a new board/tubes on new game conditions. Okay, so initially we'll just come up in our variables library and we'll make a new variable that we're going to call new game. And obviously when we boot our program up, it's going to be equal to true. Okay, and so we'll say right here, if new game is true, then what we want to do in here is we want to make some new variables. We want the number of tubes as well as all of our tube colors. So what actual colors go inside the tubes. We want those to come from a function that we're going to call generate start. Okay, so we don't actually have to pass anything in here because this function is going to determine how many tubes we have and what colors go inside them initially. So all we need to do up in our game variables is kind of set up these variables initially. So by default, I'll just set tubes equal to 10. And the reason is the version of the game I'm familiar with is random level could have 10 to 14 tubes and then always to empty. Okay, and then the only other thing we're going to say initially will be that the tube colors is just going to be an empty list. So tube colors equals blank. Because again, these are actually getting written into from the new game generate start function. So we shouldn't run into any issues with them like having initial values that don't make a ton of sense. So we'll say generate new level when initialized, like that. Okay, so let's define this generate start function, right? And just ahead of time, we know that we need to return two things. We need to return the number of tubes and the tube colors, okay? And so we'll call them something different inside the function just to keep it straight that this is inside the function. So we'll say, rather than tube colors, we'll say tubes colors and tubes numbers, okay? And so the first thing, probably the easiest thing, is we'll say the tubes number, so how many tubes we want in our level. We're just going to call random now and do rand int, which is going to give us an integer between a minimum and a maximum we give it. So again, I said 10 to 14 tubes. So we say random.randint 10 to 14. And then again, in here, we're going to say tubes colors is equal to an empty list. And now we're going to start populating it based on, how many available colors there are. And so it's kind of important to talk about a certain game mechanic here. The way these games work is they typically start you out with 2 completely empty tubes. And so if you think about how you would win a level, it's when every tube is sorted. And so you're going to have 2 empty tubes, which means you need to have as many colors as there are tubes minus 2. So it's very close to the same number, but it's minus 2. And so that'll start making sense, I think, when we sort of populate these lists. So what we're going to say is for I in range, and then the number of tubes we have. So that's tubes number here. We want tubes underscore colors dot append, and we're going to append an empty list. So initially this might seem a little confusing, but we're going to take this tubes colors list and we're going to make it look like this. Tubes colors equals, and it's going to be this list with all these empties inside, and you're going to have an empty list for each tube, but that's because each tube has to have up to 4 colors inside of it. So I'm not going to leave this comment in here, but that's basically what we're doing with this dot append. And then the next thing we're going to do is we're actually going to put colors inside of our available colors list if we haven't yet reached the maximum number of colors. Okay, so now we'll say if I is less than tubes number minus 2, right? Because remember, that's how many colors we're going to have. So if we have 12 tubes in our level, we have 10 colors. If we have 14 tubes, we have 12 colors. But so what we're going to do is we're going to say if tubes number is less than, or if I is less than tubes number minus 2, then we want to add for j in range 4, we want to add a total of 4 squares of that color to an available colors list. So we're going to say available colors dot append. But then what we append into it is going to be this I. So we're going to just basically create a list of integer values. And later we'll talk about how integer values relate to actual colors. But all you need to know for now is basically we're going to have 4 squares of color 0, 4 squares of color 1, 4 squares of color 2, all the way up to tubes number minus 2 in this list called available colors, that then what we're going to do next is populate the tubes with 4 random colors. Okay, so let's take a look at how we do that. For I in range tubes number minus 2. So again, this is intentionally always going to leave the last 2 tubes completely empty. Now what we say is for j in range 4. So it looks kind of a lot like this, right? But what we were doing here is creating our list of all available colors. Now we're assigning each tube random colors in the beginning. Okay, so what do we want to do 4 times? Well, we want to pick a color just for this one. So again, we're going to use the random tool again, and then dot choice this time, which all you do with dot choice is you give it a list. In this case, our available colors list, and the random dot choice is going to select one item out of that list. And then what we'll do is we'll say that color, so tubes color at I is going to get that color added to it. So dot append and then color. But so that's how we are going to insert color into each tube. But then we also need to remove it from our list so we don't end up with more than 4 of any one color, other than then it would be impossible to sort the game. So then we'll do dot remove that color from our available colors list. Alrighty, and what I want to do is when this runs initially, I'm going to just print one time. I'm going to print the tube's colors up here as well as the tube numbers. So the tube's number. So when we run this, Even though we're not drawing anything on the screen yet, I'm going to have it just display in the console for me all of the colors we just assigned, as well as the total number of tubes. Okay, and so this should be everything we need in the generate start function. What I want to do now is I just want to come down here where we said if new game, then generate new board. And what I want to do is I want to set new game equal to false after it does that. So we're going to say new game is equal to false once it runs. So now it's only going to create one new level when the board boots up. So let's run this. Okay, and we get a blank screen still because we haven't drawn anything on the screen. And what you'll see, I actually think I have my window formatted a little weird here, so maybe it doesn't look quite right because I have it cropped a little bit wrong. But what you see is we have this list of all of our tubes, and you can see here the last two in that colors list are empty. So we successfully created two tubes that don't have colors, and we spawned in randomly that there would be 14 tubes total in this project. And each tube, you can kind of see, gets a random color between 0 and what should be 12, because there's 12 total colors. So I guess that's 0 to 11. But if I boot this again, if I restart it, then what I get this time is only 12 and still two empties, and now I get colors between 0 and 9. So that appears to be working, but we have to get it kind of displaying on the screen and drawing on the screen. And just thinking ahead here, because we do want to implement if you get stuck, then you want to be able to reset the level and come back to it. And the best time to do that is when we generate a new level. So what we'll do is we'll create another list called initial colors, and we're going to use that copy module we imported and do copy.deepCopy our tubes colors. And so this is really important because now once we've booted up a level, if we want to come back and restart it, we have a list of the tube colors right when we generated it that won't get overwritten. If we just did initial colors equals tube colors, then anytime tube colors changes as we play, initial colors is actually also going to be changing. So it's very important that we use this copy.deepCopy for a proper reset. Okay, so now the next best thing to do will be, okay, well, if it's not a new game, so else, what do we want to do? And then in that case, we'll want to draw the tubes. So we'll want to actually draw our tubes on the screen. And so to do that, we're going to pass in how many tubes we have and then what colors are in the tubes. So tubes and tube colors, and we're going to be getting back the rectangles. So the way the game is actually played is you click on a tube that you want to move, and then you click on a second tube that you want to pour the color into. So this draw tubes function is going to be the best place to get the rectangles of the tubes that we can click on back. So just thinking ahead here, we want to get the shape of the tubes back from this function, and we want to know how many total tubes and what colors to draw in our draw tubes function, okay? And so this is probably the biggest, maybe beefiest function that we're going to have in this whole project, but it's because it's doing a lot of really important stuff for us. So tube drawing on screen with the colored rectangles inside. And this function is going to be define. I think I just called it draw tubes. Yep. So draw tubes. And just thinking ahead again, remember we're going to return the tube boxes. So that'll be a list of rectangles, tube underscore boxes, and initially it'll be just an empty list, and we're passing a few things in. We're passing in the number of tubes, so in the function I'll call it tubes num just to keep it straight, and then we'll say tube culs for colors. Okay, now let's take a look at how to actually draw this. So first thing we need to know is, did we have an even number or odd number of tubes total? Because if it's odd, then our second row of tubes has to have a bit of an offset to it, right? So let's just go ahead and check if tubes remainder, so this modulo, which is the percent sign, is basically division where you check the remainder. So if tubes divided by 2 has a remainder of 0 is basically what this line of code is saying. And if it does, then we want our tubes per row, which is a new variable I just invented. We want that to be equal to just tubes num floor divided by 2. So this is integer division that will always round down, but we just checked that it's an even divisible by 2 number. So this is going to be just an integer that says how many tubes per row we need to have. And then we also know that we don't need an offset. So we'll use this variable offset to determine whether the second row needs an additional spacing to the right or not. And then we'll say else, meaning it was an odd number, so tubes modulo 2 would be equal to 1, but it's way simpler to just say else. Then we'll say tubes per row is going to be equal to, and now it's this same tubes num floor divided by 2 plus 1. So basically the tubes per row is going to be 1 greater than this modulo operator, and all we'll need to do is when we write our second row of tubes, we just don't use the full tubes per row, we do tubes per row minus 1. That'll make a little more sense when we get to it. This is also the condition where offset is going to be equal to true. Again, as always, if you have any questions about what you see in here, just know you can drop me a comment on this video and I will get back to you as soon as I can if any of it confuses you. But be sure to keep watching because maybe we answer some of your questions in just a little bit. Okay, so the spacing of these tubes is going to be equal to our overall screen width divided by the tubes per row. So however many tubes we have in each row, we want to take the overall screen width and divide it by that number so we know approximately what space horizontally we have to fit each tube in. And we're going to use that while we draw it as well. So let's start by saying for I in range and tubes per row. So now we're going to draw the top row of tubes, okay? And now we're going to say for j in range length of tube colors at I. So this is how we check how many colors are in each tube, okay? I'm going to try to explain this well, but not take too long on this item. Basically what we're saying is for I in range tubes per row. So we just calculate how many total tubes go in each row. But then we'll say for j in range length of tube colors at I. So basically in our overall tube colors list, which is just a one row, it's not an array, it's just a list of lists for each of our tubes, our top row will be essentially half of the tubes, and we're checking how long each of those is to see how many colors are in each tube. And so for j in range length of tube colors I, we want to draw a rectangle, pygame.draw.rect on the screen. But now we're going to need to make a new list because now we're not just using numbers, we're using color choices that are going to be based on what that tube color is, right? So if our tube color at I, which is which tube we're in, and then at j, which is which color inside that tube we're using, this value, tube colors ij, is going to be a specific integer inside our tube colors list. We need that to correlate to an actual color. So let's come up to the top beneath tube colors and let's make a color choices list. And remember, the maximum number of colors we could have is going to be 12 because we made it so that the game will have up to 14 tube colors, or up to 14 tubes, and we always have 2 empty tubes when a level is started and ended. So we just need 12 colors. So let's do red, orange, and we don't need RGBs because PyGame recognizes strings of common colors, but you could use RGB values here as well if you wanted to. I'm just going to go with 12 pretty common colors, so we don't need to type in, come on, help me with the word, RGB values. There we go. All right, so we'll do red, orange, light blue, dark green, which looks really cool. Pink is nice, purple, and let's go to a second line so you guys can see all of them. Then we'll do a dark gray. Since we're on a black background, that should still show up okay. And then we'll do a brown, and then we'll do a light green, and then yellow and white. And what's really cool is we will actually, we'll always have the first 8 of these lists because the minimum tubes we could ever have is 10. But so we'll always have these 8 colors. If we go up to 11 tubes, we'll add brown, 12 tubes, light green, and so all the way up and up and up. So if you have favorite colors or your best colors, you can list those as the first 8 because the clever way we set up our generate start function will automatically handle adding one more color as needed. Okay, but so there's our color choices list, and now this little piece of code right here is going to automatically select, if I had typed draw correctly, this little color choices at whatever integer is in tube colors ij is going to select from this color choices list whatever integer value. So remember, there can only be 4 zeros, which are going to be red. There can only be 4 threes, which are going to be dark blue. And it's going to automatically select that color for this rectangle that we're drawing. Okay, so now the next tricky part is going to be knowing what position to draw it in, because it's a little bit difficult to sort of visualize this without the outline tubes in position already. But basically, we want each square inside the tube to be 1/4 of the overall size of the tube. So if we say the overall tubes are going to be 200 tall, so 200 pixels high, then we want each square inside of it to be 1/4 of that, which would be 50 pixels. Okay, so let's look at it this way. Let's say there's our color. Now we need to define the rectangle, and every rectangle gets X and Y starting position, and then width, and then height. And so let's just say that we want the X starting position to be 5 plus. So that way, no matter how wide the overall screen gets, we'll have a left border of 5, so our first tube isn't touching the left edge, which will look pretty good. So 5 plus our spacing variable, remember, which tells us how far to the X direction we want to move, times I. So that's just whatever column we're in is I, and so this spacing times I will keep moving us by our spacing variable to the right as we draw more tubes. And then the next variable, the Y position, should be equal to 200 minus 50 times J. So here's what's interesting. J is our variable that determines how many colors in the tube there are. And so if we only have one color in the tube, we need it to be at the bottom of the tube, right? So that would be essentially J is equal to 0. So this would be its Y starting position is equal to 200 minus 0, or 200. And so then the next two variables that we give it are width, and we'll just make them 65 and 50. And if you're wondering where I got 65 and 50 from, I just did the math. The maximum tubes we could have on the screen would be 7. And so if 7 basically divided by, or 500 divided by 7 is fairly close to like 71 or 72. So I picked a width that would be smaller than that. So even with our max tubes, we'd still have a little gap between the tubes, which just looks good. So I picked that the tubes would be 65 wide. And I picked 50 tall because I'm going to make our overall tubes 200 tall, and there's 4 colors in each tube. So we'll make each color square 50 tall. So that's where those variables come from. You're welcome to just trust me on it. But hopefully if you're thinking about where these numbers come from, that helps explain it. And then we're going to give it 2 more arguments. We're going to give it a 0, which means we want to be a solid rectangle, and then a 3, which means we want to be rounded at the corners with a radius of 3 pixels. Okay? So this handles drawing the inside colors for the top row of tubes. Yeah. But now we want to draw the outline of the box, and it's very intentional that I do this second because I want the outline of the tube to show up over top of the colors, but in the same exact footprint. So we want another pygame.draw.rect, but this time we're storing it in a variable because we're going to return this so that we have it in the outside world. Okay, so pygame.draw.rect, we're going to put it on the screen, and I'm going to make the outline an easy to see color, which is bright blue, but I'm going to use a color that wasn't in our color choices list. You'll see I used light and dark blue, but not regular blue. just because it pops against the background. You could just use white. You could use gray or black, I guess, but we want to pop against a black background. So I'm going to make the outline blue. And then the overall outline for this is going to look fairly familiar to what we just did for the colors. It's going to be 5 plus spacing times I, because it gets the exact same X starting position as all of the color inserts. And then we're going to make the Y starting position for this just 50, right? So if you think about the math that we did, the top color, so if J was equal to 4 or 3, right? Because it could be 0, 1, 2, and 3. If J was equal to 3, this would be 200 minus 150. So our top color block will start at 50 pixels down to have this nice 50 pixel cushion at the top. So our overall tube will start 50 pixels down as well. And then we're going to make it 65 wide and then 200 tall. So this is as wide as our color blocks and then as tall as 4 of them stacked together. Now this, we do not want to be a solid rectangle. We want to be a hollow rectangle. So we'll make it outline of 5, thickness 5. So this is going to make the edge thickness 5, but then hollow inside of that. And we'll make it also a rounded rectangle with radius 3 for the corners as well. And let's just see how that looks. So next thing we'll do is just do our tube boxes dot append our box, right? So as we draw these, it's going to just add one at a time each rectangle to our overall box. Now, before we go on and look at doing the second row of tubes, let's just make sure that looks good. So if I boot this up again, all right, I get a row of tubes. So we get 7 tubes, which was actually the maximum number. And you can see we have all these different colors drawn in already. We're not doing anything actively to control them. But if you see in the bottom of the screen here, we had one tube that was 0005. And again, I kind of cut off the first tube, but you can kind of tell it's the second tube should be 0005. And you can see we've got this red, 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 pink. So it's turning these integers from our generate level program, our generate level loop, and it's turning those integers into actual colors using this function. Okay, so that is super cool. That's super fun. Let's go ahead and take a look at how to extend this to the second row of tubes. Okay, and this is a little bit complicated, but very similar to what we just did. So it's going to be a lot less typing. But we need to check if we have an offset, right? So if we have an odd or even number of tubes. So first, let's say if we do have the offset, then we need to say for I in range, and now it's going to be tubes per row minus 1, right? Because that's how many tubes are left. If we had an offset, that meant that we had an odd number of tubes. And so we're going to draw the larger number of tubes on top always. It's just a design choice. Technically, you could do the odd number of tubes on top and then the even number on the bottom if you wanted. Doesn't matter, but I'm going to make the second row the one that varies. So then we'll say for J in range and then length of tube colors, but this time it's a little complicated. It's not just tube colors at I. It's actually tube colors at I plus the tubes per row variable. And that's because, so tubes per row. And that's because on the second row, we've already done one full row of tubes. So when we start counting up, so for example, if we had 7 tubes per row, this first loop is going to run 0, 1, 2, 3, 4, 5, 6, but not 7. But then on the second row, we need this to start at 7 and go till basically 14, which would be 13 because we start counting from 0. But so our second row actually needs to check the tube colors at I plus tubes per row. Okay, hopefully that explanation made sense. I know it's a bit of tricky keeping the math straight in your head. But now the next piece can look very similar to what we just did. So I'm going to grab this pygame.draw.rect from above for the colors. And now I'm just going to say screen, and then color choices again for this one is no longer just tube colors at I, it's I plus tubes underscore per underscore row. And so another thing you could do if you really want to is you could say for I in range from tubes per row up to tubes per row times 2 minus 1. And that way you could just use like basic I. But let me format this so you guys can see everything on just 2 lines here. Okay, but this is actually still pretty easy, okay? So now it's just checking the tube colors at I plus tubes per row so that we're checking into the second row. And then now it's going to still be 5 plus spacing times I, but we need that offset, right? That was the whole point of the offset variable. And that's going to be equal to spacing times 0.5 plus our original. So let me move this whole rectangle down. I know I keep scooting stuff around. But so basically our X starting coordinate is going to be the same as it was above, except we're going to shift it over by 1/2 of our spacing variable. So that's what this is doing here. It's pretty cool. And then now our Y coordinate is no longer going to be 200 minus 50 times J for the second row. We need to move it down by so essentially we're using 50 pixel gaps everywhere with 400 height tubes. So we need to move it down 200 for another tube, but then another 50 for a nice cushion between the 2 rows. So we're going to say 450 minus 50 times J, but then still 65 wide, still 50 tall, still a solid rectangle, and still rounded with a radius of 3. Okay? And now I'm going to take these same 2 rows of code, the box and the tube definition, and we are going to move them a little bit. So still blue, and we need that same spacing offset that we put on those other guys. So boop, doop, just like that. And then this one, instead of 50 like it was above, will be at 300. So again, think of it kind of the maximum this could be would be J is equal to 3. So 450 minus 150 is 300. Okay, just like above, pretty straightforward. And now that's going to get all of these tubes into our list as well. And so we're going to take this whole if offset code and we're just going to quickly add an else to it, right? So basically, before was if offset. Now we don't even have to say if not offset. We can just say else. And now instead of tubes per row minus 1, it's a full row. So it's for I in range tubes per row, just like before. We keep the I plus tubes per row for checking because we are still in the second row. But what's nice now is we can get rid of this spacing factor. So this spacing times 0.5, because now we're saying we don't need it to have an offset. So for both of them, it's just going to be our normal 5 plus spacing times I. Nothing else has to change. And we still just append every outline of the rectangle to the boxes list. And that should be all we have to do now. If we boot this up, we should get 2 rows of our colors. And okay, so something's off. Let's see, because we had 14. We can see down here we had 14. 2 of them should be empty, but we're not getting outlines for a lot of these. So let's check out what maybe we did wrong on drawing the outline rectangles down here. Oh, it's very simply a formatting issue. We need these tacked inside of our for I in range list here. We need to use each I because otherwise we're just going to get 1 second row. So that should be all it is. Let's take another look. There we go. We get all of our outlines instead of just that last one. So just a silly little formatting thing, but that does show a lot of the comments I get on my YouTube channels are people who have questions like something doesn't seem to be working. I copied your code exactly. And I'll respond to the comment like, hey, just double check your tabs, double check your indentation everywhere. And then usually I get a response the next day. Yeah, I got it figured out. It was indentation. So it happens to the best of us. It happens to all of us. And so just keep your head up and make sure to keep an eye on syntax and things like that. Okay, so we should be really proud of what we have already. We basically have this code that randomly generates levels, and you can see here's one with an offset. It looks great. It puts them right in between the row above them. So I'm really excited by this. The next thing we need to do is really just handle how to select, right? So how to click on a different tube and kind of check if we're able to move colors from one tube into the next tube with our clicking. And this will be really easy because we're getting back an entire list of tube rectangles. So we'll use those and PyGame's built-in collision detection in our event handling to handle what to do if we click a tube. So let's check that out. If event.type is equal to PyGame dot, and now it's a new type, it's going to be mouse button down, which basically means we clicked. All right. And so let's make a new variable, right? Because there's basically two clicks. There's a click to select your first tube, and then there's a click to select your destination. So we'll say first, if you haven't selected a tube, so if not selected, and we'll have to make this variable, then what we want to do is say for item in, and this is going to check how many total rectangles we have. So tube rects, for item in range, tube rects, and this actually needs to be length of tube rects. What we're going to say is if tube rects at our specific item, so at whatever number we just checked, if it dot collide points with event dot position. So event dot position is going to come from this event dot type mouse button down, which is going to give us an X and Y coordinate of where the mouse was at when we clicked something on the mouse. And we're using this PyGame built-in function .collide point, which works with PyGame rectangles. So every item in this list is a PyGame rectangle. We do .collide point with event position. And so if it does collide, then we want to set our selected variable equal to true. And we also want our select rectangle. So whatever rectangle we just selected, we want that equal to whatever the item. So this is the index value. But since this is not inside of a function, I don't want to use I. Then it throws a whole bunch of like context like, oh, you're using I in the outside world every time you use a for loop in the function. So I'm just using item as my index. And we want to keep track of what item we clicked on. So we're going to set that equal to select rect. Okay, so initially, let's just come up here and define these variables. And I'm going to start by sending selected equal to false when the game boots up. So false. And then I'm going to set select rect equal to a rectangle that could never actually be in the code. So I'm going to set it equal to 100. Just it's basically a nonsense value. But even if I were to put a 0 here, it would represent an actual rectangle on the screen. So I'm just using 100 because we'll never have 100 tubes. Okay, so that's going to be how we actually click on a tube. And then what we want to do is we want to say, okay, well, what if we have selected something already? Because then a click means something else. So else, we're going to use this same collision detection, right, for item in range tube rects, because the only way to play this game is to click on tubes. So we'll say else, we have already selected a first tube. Now we're checking to see a destination rect. So instead of select rect, we need to have a destination rect. But then what we'll do is we'll set selected equal to false because we've clicked, and we'll set the select rect back to something we could have like never used. But what we need to do before we overwrite this is we set destrect equal to item. So let's do that first actually, and then we'll reset kind of our clicking stuff second. So we set destrect equal to item, and then we need to check and see if we need to rearrange our tube colors list based on whether or not that was a valid move. So we need to create a new function called calculate move. All right, and in here we need to pass what the tube colors currently are, and then we need to pass in what the selected rectangle is and the destination rectangle, right? Because basically all calculating a move is going to do is check what tube colors we currently have, check what was selected initially, check where we want to send it, and do the math to see if that's a valid move. All right, so we want to make our destination rect initial variable as well. So we'll do dest rect, and we'll set that equal to 100 as well. And because until we've selected something, it's not useful to have that. All right, and now we're going to check out the calculate a move function. So let's go below draw tubes, and let's put a row in here about what this is doing. Determine the top color of the selected tube and the destination tube, right? Because that's how we determine if we're allowed to move a color. It needs to either be the same color in our destination tube and the tube can't be full, or it needs to be an empty tube. Okay, so that's the first one. So determine the color and then check how long a chain of that color to move. So again, if you're trying to move 2 reds into an empty tube, most of these color sort games don't let you move half of that at a time unless you're filling a tube. So if we have 2 reds and you click on an empty tube, both those reds are going to move. That's the normal way to play. So we need to handle all that in this calculate move function. And in here, we're going to pass in the colors, the selected rectangle, and then also the destination. So I guess we want it like that. And we need to remember the only thing we're returning out here is going to be the colors. Okay, so if we had a valid move, then we want to return the colors. Alrighty, so let's take a look at this. Let's initially set this variable chain equal to true because we're going to check and see how many continuous squares are in that chain. And so initially it'll always be true because every chain will be at least 1 long. So if you have 3 reds stacked on top of each other, this chain variable will eventually determine that the length is going to be equal to 3. But initially, the length will always be 1, and we'll always want to check for a chain. So we can do it like that. And then we're going to have these 2 variables, the color on top. So that's going to be essentially checking what color was on the top of our selected rectangle. And then we're going to check our color on top will be in the destination, and then color to move will be in our selected rectangle. And we need to check that these are either the same or that the destination is empty, right? So let's get into how we're going to do that. And again, I'm giving these nonsense values just so that they don't accidentally move like a red when they're not supposed to for any sort of weird reason. And this would throw an error like list index out of range if we do something wrong. So it's just kind of a check that something is off. But so what we're going to do first is we're going to say if the length of colors in our selected rectangle is greater than 0. And this is actually important because if you select a rectangle with nothing in it, we can't possibly move something out of it, right? The length of colors of the selected rectangle has to be greater than 0 or we have nothing to move. All right, and so if it is greater than 0, that means that we can set our color to move value equal to whatever the last entry in our selected rectangle is. So colors selected rect at -1. And maybe you're not familiar with -1 addressing, negative addressing to a list if you're not familiar with Python or object-oriented programming. But in a list, since if you only had 1 color in a tube, it's the bottom square. But the way this game works is you can only ever move the top color out of it. We need to check what the last item in the list is. And you can do that by doing this -1, which is going to mean if there are 3 entries, it's going to check the 3rd entry. If there are 2, it's going to check the 2nd, just by saying go to the end of the list and pick basically the first one at the end of the list. And that's going to be our color to move. And then what we say is for I in range length, and actually we want to start at 1 because it's always at least 1 when we select a tube. So from 1 up to the length of the colors list for our selected rectangle. All right, so if there's only 1 color in our selected rectangle, length is only ever going to be 1. But what we'll say is if chain. So if we haven't yet broken the chain of same colors, we'll say if colors of our selected rectangle at position -1 minus I. So again, we just covered what negative addressing is. But basically this is saying initially if all we have is 1, right, then we're going to check and see if colors at -2 is equal to the color to move that we just checked. So if it is, then that's great. We'll say +1 to our length. Okay, so length plus equals 1. But then we need this else, which basically means, nope, we found a different color in there. And then that's going to make chain equal to false. So again, I don't want to get too super complicated here, but this is basically the way to check if the color directly underneath the top color is the same color as the one on top. And every time it is, we want to add one to the chain. So it could at a maximum be up to 4 tall, right? Theoretically, you could move a tube filled with 4 reds into an empty tube, and we want all 4 of those to move, right? So let's check out how to do that. Alrighty, so we need to check if the destination that we selected is even a valid destination to move colors. So that is going to be a check to see if the length of colors in our destination now. So the colors list for our destination tube has to be less than 4. If the length of it is 4, it's full and we can't put anything in there, all right? But now we also need to check if the length of our destination tube is 0, because if our destination tube is equal to 0, we are always able to move the color in. So then what we'll basically say is the color on top is allowed to be equal to the color to move, okay? So there is no color on top, and the way we're going to check if it's a valid move or not is to see if the color on top is equal to our color that we need to move, and if it is, that's when we're going to allow movement. All right, so color on top is going to be equal to color to move automatically if the destination tube is empty or has a length of 0. But otherwise, there's something in that destination tube. All right, so else color on top is going to be equal to, and now this should be getting a little more familiar every time we do it, but our colors list at destination at address -1. So whatever the top color in our destination tube is, that's the color that's on top in our destination. Alrighty, so how do we check if it's allowed to move or not? We say if color on top is equal to the color to move. All right, so that is how we know whether or not we are allowed to move material. And so the only way color on top is going to be equal to color to move at this point is if they're both empty, which is fine, or if selected has some color in it and either the tube is empty or the top color of that tube is the same color. All right. Then what we'll say is for I in range length, right? So we figured out how long that chain was from the selected tube. And what we'll say is if the length of colors at our destination is still less than 4, because if we have a chain of 3, but we only have 2 available squares in our destination tube, we can't keep sending material there. So it needs to be if the destination tube is still less than 4, so it's not completely full, and if the colors selected rect is greater than 0. Okay, so this means we don't have an empty tube. So this is basically just a check against both tubes being empty and throwing an error by trying to move a 0 in there. But then what we'll say is that, okay, colors in our destination list, so colors destination dot append color on top. So we're going to add whatever color was on top of our selected rectangle to our destination list, and then we need to pop that out of our selected rectangle. So colors selected rect, and then this dot pop, and we give it the index to remove. So it's always going to be whatever color was on top. And it's actually going to do this so fast. Excuse me. It's going to do this so fast. Looks like I have one too many indents for everything. There we go. It's going to do this so fast for us that it'll look like it's moving all 3 rectangles of one color at the same time if we have a chain, but it's actually going to do it 3 independent times in this for loop. Excuse me. All right, so that should be everything we need to do to get movement working. So let's go ahead and minimize that. And let's just take a look at if we're able to move colors now. So I see we've got 2 whites. Let's try to move white into here. And it's actually right now, first thing I'm noticing is it's very difficult to tell if we have something selected or not. So what I think we want to do is actually come back into our draw tubes function and add a check to see if we've selected a rectangle. And if we have, let's highlight it green. Okay, and I actually think this will be really easy. We just want to go everywhere that we have a box definition, so a box like this, and we just want to say if our selected rectangle, select rect, is equal to I, right? Because that's whatever position we're in here. So if it's equal to I, then let's draw this same rectangle, but let's make it green. And instead of a border of 5, let's have it a border of 3, just kind of for a cool 2-tier effect. And then what we need to do is just down here, we need to say if select rect instead now is equal to I plus tubes per row, right? And then the same rectangle. So this whole rectangle, and we just want it to be green, and an outline of 3. And this is really important because we need to be able to tell if we've selected a rectangle or not. It's really important to playing the game. Some versions of the game will have it be like the tube will actually raise up if you select it. We'll just have it highlighted green. So let's check if selecting is working. I want to select this one and it goes green. What if I click somewhere to deposit it? Okay, so we have a greater than, we have an error on line 109. Let's check that out. It was in our calculated move function. This is what testing is for. If colors selected rect, oh yes, this needs to be length of colors of selected rect. Okay, so this important when you try to check how long something is, you need length. So let's see if that fixed it. So I'll select this purple, try and move it over here, and we get a purple over there. All right, I'm gonna try to move a purple on top of it. Great, now I'm gonna try to move a red on top of the purples, and it doesn't work, nothing happens, but I can move these dark blues around, I can move these grays and greens around, and this is amazing. This is the basic functionality of the game. All we have to do left really is check game over conditions and then draw some stuff onto the screen so they know how to reset and restart and generate a new board if they want to. But this is amazing. We have the core functionality built out in under an hour in barely 100 lines of code. This is great. Okay, so basically the only thing left to do is for checking for victory conditions and then enabling restarting and creating new boards. And attentive viewers will notice I got a haircut because I had a haircut scheduled in the middle of my recording time. But now let's get into it. So checking for victory is actually going to be really simple. We're just going to come below where we were drawing the tubes, and we're just going to check for a win every single time. So basically, we're going to use this variable that's just called win, and we're going to create a function called check victory. And the only thing this function is going to need to know is the current colors in the tubes. That's all the function needs, because all we're doing is going through every tube and making sure that it's either completely empty or it's full with 4 colors, all of the same color. So that is what's going to determine whether we win or not. So initially, we'll just come up and we'll initialize win equal to false when we first boot the game up. And now we are just going to make one more function. So come down below all of our other functions, and we will just say this one will be check to see if victory conditions are met. All right, and so define check underscore victory, and all we need to pass into this one are the colors, right? Just the colors, and then we're going to return, and we'll call it 1 inside of here. And so the theory of how I'm going to check through this thing might seem a little backwards, but I'm actually going to start by setting this variable 1 equals to true. And then I'm just going to check through all of our colors and see if anything that would make that not true is active. And if it is, we're going to set 1 equal to false. And otherwise, by default, 1 will stay true. So basically, all we have to do is a for loop that'll check through for I in range length of colors. So this is going to check through our list of every tube and all of the colors in the tube. And what we'll do is we'll say if the length of colors at I, so whatever tube we're checking, if the length of it is greater than 0, then we need to check if it's greater than 0 and it's a full tube, so if it has 4. So then we'll say if the length of colors at I is not equal to 4, then 1 is equal to false, because this means that we have a tube that is not empty and it's not full, right? So to win a game, you need to have every tube full with 4 pieces, and you have to have 2 empty tubes. So if you have any tube that has 1 piece, 2 piece, 3 pieces in it, then you're not going to win. But then we'll say else, because then that means we do have a tube with 4. We'll say main color, or you could call it first color, is going to be equal to colors I and then minus 1, right? Whatever's on top. And then we'll say for j in range, length of colors I. And some of you sharp programmers probably see that we could actually just say for range 4, because we've already checked that length of colors I is going to be equal to 4, but this is a little bit more robust way of writing it. For j in range, length of colors I, we'll just say if colors at I, j is not equal to the main color, so that first color on top of the stack, then 1 is equal to false. And that's all we have to do to check if we've won or not, because by default, we're going to say, all right, check if there's a victory. And then we go through every tube. And if it's empty, or if it has 4 pieces and everything in it is the same color, then we won't trigger 1 equals false. We'll just say, yes, you won at the end of it. So this is a really easy way to check if you've won. And it's also, it's just a really simple function that's going to return this variable win, but we don't do anything with win yet. So let's just take a look at kind of adding some stuff down below everything else. So at the very bottom, all we're going to do is display some stuff on the screen. So we'll say draw victory text if we have won, and leave instructions on how to restart and get new board, right? So we are going to put functionality in here for giving like congratulatory text if you've won, but we'll also explain how to restart and how to get a new board. So let's start by saying if win, right? So if we've won, then we'll call this text victory text, and it's just going to be equal to font.render. And then we'll say you win, press enter for a new board. And then this font.render needs 2 more arguments. It needs anti-alias, which will be true, and that basically just smooths out the text. And then we're going to say the font should be white, the text should be white, and we will screen.blit, or block transfer draw, onto the screen, and you give it what text to transfer, and that'll be victory text, and then x and y coordinates. And we left that nice 50 pixel gap right in the middle of the screen, and that's kind of where we're going to drop this. So 30 just to get it away from the left wall a little bit, and then 265 to put it right in the middle. And then we'll do 2 other things. We'll call this restart text, which will just be another font.render like before. And this one will say stuck, question mark, because it is possible in this game to paint yourself into a corner so you can't get out. We'll say space is restart, and then enter is new board. So really you can get a new board at any time. It doesn't have to wait till you win. And then we will say, again, true for anti-alias and text white. And then let's screen.blit, and let's go ahead and say restart text, and then let's put it at 10, 10. So this will be right at the very top the whole time you're playing. So that's why we put it outside of the if statement. Alrighty, and so the last, so we can boot this up real quick and just make sure that the top text is there, and the bottom text isn't there yet. It should show up when we win, but I'm not going to play through this whole level right now just to bore you guys. So first, let's put in the code for what to actually do on space or enter, right? And it's going to be pretty easy. Let's just come below quit, but above mouse button down, and let's add a new event type, which is going to be if event.type is equal to, and you can do pygame.key down or key up. I usually actually do key up, because on key down, technically if you were like holding it down or it flickered, you could do this several times. I just do key up because that's when you actually release the button, and so getting duplicates is less likely, but either way would work. And first let's do space. So if event.key is equal to pygame.k underscore space. And so that's the space bar, which we said would be a reset, right? So stuck, space is going to restart. Well, how do we restart the game? It's actually just we need to set our tube colors. So whatever state our level is in, we need to set it equal to copy.deep copy of initial colors. So in the same way, then when we create an initial level here, we make initial colors a deep copy of tube colors. We want to make tube colors a deep copy of initial colors. So when we generate the board, we save a copy of the state of the colors in this initial colors variable. And then anytime we want to reset the board, we set colors equal to a copy of the initial list so that neither overwrite each other as you play the game. Next is going to be an elif event.key is equal to PyGame dot k, and then it's actually, we're doing the enter key, but PyGame calls it return. A lot of older PCs and a lot of older computers had return on the enter key, and I think that harkens back to like typewriter days, so it's just called return. You just need to know that, but it's really easy. If that's the button that gets pressed, all we're going to do is set new game equal to true. And we've set these functions up to where they're going to automatically create a new board with a new number of tubes and a new colors list and everything just by saying new game equal to true. And that should be all we have to do. So let's go ahead and boot this up. And I'm just going to move some stuff around. I actually got 3 reds. That's kind of cool. Let me just move a few pieces around. And I'm going to hit space, which should move everything back to its initial state. So let me maybe mess it up a little bit more so it's more obvious that we have a new board, right? So I'm doing okay, but oh, looks like I got stuck. I don't have any more valid moves. If I hit space, it gives me the board back, right? See, we have this very recognizable 3 reds here. But if I say, oh, this level is too hard, I don't like it, I just want a different board, I'm going to press enter now. There we go. And it gives us a new number of tubes, a new configuration of the board. And now let's actually play it. I'll try to do this quickly so I don't just bore you guys. But if you watched this long, you're probably actually genuinely interested in the project. Man, I can't beat this one. Let's see if I can get an easier one. Let's try this. Because I'd like to verify that the like new board code works, but it's a little difficult to play the game while being watched here. I may cut me actually playing it to just wherever when I actually get a level beat, but let's see here. Have I gotten stuck already? Nope, there we go. There we go. Okay, all right. We're doing pretty good here, moving right along. And there we go. So this should give us, you win, press enter for a new board, okay? So that's really cool. This is kind of the basics of the entire game. My suggestion to you would be if you want to take this an extra mile, you could implement like a scoring system where you get like a total number of points for every level that you complete, or every time you fill a tube with 4 of one color, you get a certain number of points. You could save score to an external file. You could ask a user for like a username and then keep track of what user has beaten the most levels, things like that. If you need that kind of add-on stuff, if you need that sort of PyGame education, I suggest you check out the full PyGame tutorial playlist on my channel. I have done basically, I think 50, maybe 100 tutorials on PyGame on my channel, and we cover everything from reading and writing to external text files into your game, to sound effects and movement and animation. So any way that you would want to extend this game, one, it would be great for you as a programmer to get that experience and build off it yourself. But two, I've probably done a video on the channel teaching you how to kind of get close to that next level. So be sure to check those out. I hope you found this tutorial useful. Please consider leaving a like on the video, subscribe to the channel. If you really love my content, you really want to help me grow, you can check out the Patreon link in the description of the video as well. If you're here and you watched the whole video, I appreciate you so much. Thanks for watching. Let me know in the comments what you want to see more of in the future. And until next time, good luck with your projects, and thanks for watching. Bye.